Yeah, this session is recording now. Hello everyone, my name is Anton Komlev. I'm technical leader in ARM in the Trusted Firmware M project. On behalf of trustedfirmware.org, we are starting this technical open forum. Today we have a very nice and interesting topic. We are planning to do it for a long time, and this is the first step to introduce hardware abstraction layer. And this is the first step. And this is, why shall I talk the thing what Edison did and can be proud to present it himself. So Edison, please.
Yeah. So let me share my screen. So can you see?
Yes. It would be good if you are not planning to say or ask questions, put you on mute. Thank you very much.
I will start. Okay. My topic is the trust firmwares for ARM's hardware abstraction layers, and this is the main agent. First one will give a basic introductions about the TFM health, and then is overview structures and introduce the APIs categories. And the last one is give some the appendix for some date. So the first one is the introductions. So the TFM health is the higher layer interface, and then it is not a device driver API. So it's very important and very different with the we normally call what is the hair. Okay, so the second point is the TF hair is the abstraction hardwares, and it's mainly abstract hardwares or oriented operations to support the hardware difference, and it's make TFM easy to use the hardwares and make it easy to develop the core and the service that need to access the devices. And the third point is its portability. So it will help users more quick and simple porting to different platforms. And the last point is it is easy to maintain. Because with many different platforms start to integrate the TFM, so it's so our APIs will be need to support the future updates and maintenance. Yeah. So this is the overall structures. So we can see here the hair is based on the platform source, and it will cover the different hardwares. For example, the MPC, PPC, Flash, UART, and timer hardware is critical. Yeah, and the hairs can be separated to main parts, and the first one is for the TFM core, and the second one is for the skill partitions, peripherals. Yeah, and you can see here the core part will consist these 6 main parts: the platforms, loaders, solutions, log device, and interrupt and debug. And then I will give APIs categories. Yeah, so we can see the details. For the platform APIs, there has 4 interface for it: the init, reset platforms, get platform profiles, and hair versions. And for the solution APIs, it's mainly to provide the necessary solution functions that required by the PSA-FF, and maybe follow the TPSAM, and provides functions to SPM to check the validates of the memory access. So there are mainly 4 APIs for it: the create isolation regions, destroy isolation regions, and the switch isolation regions, and access to regions. So for the loader APIs, it provides the functions to load partition and the service, and provides the necessary data to the SPM. So it's mainly two interface for it: the loader partitions and the loader service. And for the then it's for the log device APIs, there are two interface for it. One is for output the call log, and the other one is output the service log. And the last one is the interrupt APIs. Also has 4 interface of it: config IRQs, enable IRQ, disable IRQ, and clear pending status. And besides this, there are also the SP parameters, SP device health. So it is in the next steps, and but it is still in investigating. So we will introduce it in the next time. So other one is the debug. So the debug features will be enhanced in future. So in this time, so we also there are also some debug initial, and which has been included in the platform init. And another one is for due course, and there has some due course health interface in the current TFM designs, and the decal path is just follow the current design and not be covered in this here. So I will give the detailed interface, detailed introductions about interface. So Bezens, do you any questions about the APIs categories? Okay.
Edison, I think you forget to mention that this API was shared already, I think 2 weeks ago, and it's available so everybody can see it in detail. So today we planned to overview and answer questions instead of going into function investigation. And all feedback are still welcome and expected.
Yeah, of course. Okay, let me make a news. So the first one is for the platform internalizations interface. So the pod tabs is the TFM health in its platforms, and there has one input parameters, which is measurements. Let's say what's it measurements? It's hint, and it's input by the SPM to the platforms to tell the platforms what should do in this interface, and the platform experts to set the repeat speed after each operations, and the platform need to return back this measurement new status to the SPM, and then SPM will use it to check the elements between it with the platforms. So for example, if we ask to initialize the solutions and debug on the log, and if the platform, it's just an example, if the platforms returns the status not include the solutions, so SPM will panic the system, so because it's the fat error for the TFM. So this interface will cover most of the initial functions. So let's see the right pictures. So we can see that in the examples of the init platform APIs, there has many initial functions. For example, the clock configurations, the isolation init, interrupt init, and system reset config, and debug init. So So we can say it has it will cover the most of the initial APIs, and so in the next API definitions, as you can see, there will know the initial API because it has been covered in this function. And the second.
Sorry, Edison, one question. So can you clarify more details about what's the measurement? So for example, can I just measure the interrupt init and ignore isolation init and the clock configuration in the higher unit platform?
No.
So
yeah. So no. The answer is no, because the TFMs will input the measurement element to the platform and to tell so what part we want. For example, the isolation. The isolation should be the requirement because it's the basis of the security. Yeah.
Okay.
We will give maybe some part requirement, some part may be optional. So for the requirement, the platform must be implemented all of them. If one escapes the SPM, the TFM will panic the system.
So the idea is to probe the capabilities of the platform. Is it correct understanding?
Yeah, just it's just some hint to the platform and the tell platform what need to do in this API.
Yeah, the measurements provides their a set of bits to tell the platform these things you need to do. And the platform, when platform finishes doing something, it will clear or set the bit. The mechanism is not decided, so it will clear or set the related bit. And finally, platform will return the final result to their SPM. SPM will double check if the result is expected. So that's their basic concept, I think.
Yeah. So I will continue. Yeah.
Sorry, I got one more question for you.
Sorry?
There is no regarding the fact that the platform sets
Sorry, is this a question?
on the measurement.
Gentlemen, if you're not planning to use your microphone, could you put you on mute? I can do it as well.
Okay. So next part is the skill partition loaders. So first one is why we need it. Why we need it because the platform decide where to put all the partition regions, all the partition informations, the memories, the interrupt, yeah, and the second one is the platforms allocate the memories in the linker stage for the skill partitions. And the third point is SPM is a logic implementations of PSFF. So it should be only focused on the partition management. So this is why we need the platform to provide these APIs to the SPM to load the partition to load the partition and provide the partition information to the TFM and so the second part is the platform need to provide all the necessary memory to SPM. So that means so what is the necessary memories? Is we can see the above pictures. So for the partition, it's mainly includes 4 parts. the partition static date. So it should be the code date, read-only date, W date, and stack heap. The second part is the platform date. It's used for the MMIO and peripherals, and the second part is for the interrupt date. And the last one, yeah, it's the runtime days. So this is runtime days that is not for the SQL partition and is not for the platform. So it is for the SPM. So because SPM will use this to management as a SQL partition and save some context on these regions. So we requires the platform to provide these 4 parts of data to the TFM. So and for the service, it's little same with the partitions, but only 2 parts for it: the service static date and the runtime date, and also the runtime date is just for the SPM. Of course, we will give 2 macro here to indicate how many stats we need, and the SPM, the platform need to allocate the necessary memory stats according to these macros. Yeah. So what changed to TFM by this loader APIs? So we can see the left is the current status of the TFM database. So in SPM, we have a big SPM database. For example, it's for the SQL partition ones. There has the platform data memory, static and runtimes, and every element will point to another big arrays, data arrays. For example, the platform data arrays, the static data arrays, the memory data array, and then the SPM platform data will point every big data array. Yeah. So what do we want to change? We will move all this data to the platform. You can see the right. And this is the first change, moves the data from the SPM to the platform. The second change is split the big data arrays. That means there will no big data to, for example, the platform data arrays will include every SQL partition platform data. And in the new designs, we requirement the platform to split the date by the SQL partition. For example, for the partition SQL partition ones, maybe there will need dedicate header fields or C fields. It will includes on the this partition date, the platform date, interrupt date, and static date. So it is different with the formats. Yeah. So in this case, every SQL partition will has its dedicated date source files. Mm-hmm. So any questions for this?
Sorry.
So
yeah, in the proposal at the right, so why SP1 stays in platform scope? What does it mean by putting SP1 in the platform scope? So yeah.
So no, let me say it. the platform is the platform will decide is how to put it and where to put it. And for the details of these regions, we will need some tools to export the data from the manifest to a dedicated file, and then the platform will decide is where to put these dates on the linker files, on scatter files, and yeah, and the platform need to decide how to place them. Mm-hmm.
Yeah, I know that's in current proposal, the memory layouts of these SP data is provided by platform, but my question is the diagram seems a little confusing because there are several pieces of block to indicate the data. So which blocks indicates the memory space to store the data, and what's the purpose of other blocks?
I think in the right pictures you can see the platform date on the right list. There has three blocks: the platform date, interrupt date, and the stack date. So then this should be the memory space to put the data information. And another one is the runtime date. The runtime date is also the memory space, and it is provided to the SPM directly, and so we don't need to another place to put the dates. So okay. So for the three members in the SP in the red pictures for the SP platform data is just a pointer. The platform date SP1 platform data, P1 interrupt date, and the SP1 static data is just a pointer to the right memory space. Yeah.
Okay, so where do the pointers stored?
It's decided by platform. Yeah.
So so is there another API to store and load the pointers?
No, it's just these two APIs: load partition. The load partitions, the return values is the pointer, this structure pointer. Mm-hmm.
I think the main confusion is that in the left side, you don't need to mention the difference between the SPM and platform. Actually, in the existing implementation, and actually all the memory data are the region for saving their info or their scripting data is all called as SPM area, I think.
Mm-hmm.
So which means that you don't need to create different colors for that. So after we applied the new load API, I think it is still the same because all the memory are decided by platform. So just some fine tuning need to be done in the data structure, and something need to be changed. So I think yeah. So if you don't need to make a difference in the left side to distinguish the SPM and platform, and
Yeah.
And if we don't distinguish their color in the left side, then we don't need. Then looks like the left side and the right side are all the same. Yeah, that's the confusion here, I think. So maybe we need to update it.
Mm-hmm.
So my concern is because the platform data arrays are so important and sensitive. So do you have provide a mechanism to add the data arrays into one step of the root of trust, such as the secret boot? How you can authenticate those kind of status, and how to guarantee they are not unchanged?
So I think for the boot date, for the boot date, I think that in currently in current TFMs, there only one boot date, and it is used by the attestation. Yeah. So attestation is a secure service, and this is not part of the TFM core. So this here is just for TFM core. And for the attestation, the secure attestations, the health is different. So because the attestation can declare some memory resource in his manifest, and it means that he will need he want to access some important memory space, and SPM can help configurations to the MCU and PUs, and can let the attestation to access this memory region. Of course, the attestation need to is the PSA route. So the application also cannot access this region, memory region. So it should be memory protect.
I think the question should be why we just direct play their data array here. So do we have some authentication or something for that? So the answer is there at the current stage, all the TFM secure firmware binary are built together. So which means that the whole secure firmware imaging has a signature for the whole their binary. So which means that now we use a static placement here, so we don't put the authentication date for each of the data array. So the reason why we proposing such a load API is for the upcoming features. In the upcoming part, they would be a customized placement for this data array. So for example, maybe each SQL partition may be created as a binary and they are integrated in the system. So in that case, the higher design needs to do the authentication in their load API while loading the SQL partitions. So here we just introduce their existing design as the first step. So if there are some other mechanism to integrate the whole system, so they need to update their implementation of the load API. So that's there.
Yeah, thank you, Ken.
So if we understand, it means that in the future we will be able to update the secure, I would say, side with a new secure partition, or we will be also able to update an existing secure partition. This is what you mean?
From now, we try to actually it is something like implementation defined thing. So yeah, so we just try to abstract their load API to give the possibility to support that. So yeah, what I mean is that we don't have a solid plan for that. So, but it is possible.
Okay, that's something we are looking for on ST side. So that would be very interesting too. Okay.
Okay. So sorry if I did not get your question first time. Yeah, thank you again. So no other questions that I will continue. So next one is the solution interface. So there has 4 solution interface. So it's just examples. The TFM health create a solution regions that is used to create the protect regions for secure partitions. and you can say, the example, there has two partitions. Everyone has its isolation protect regions, and then is the switch isolation regions. It will use in the schedulers because before we jump to the partition, the scheduler will call these APIs to let platform to switch the isolation regions to, for example, to switch out the SP1 and switch in the SP2, and then jump to the SP2. Yeah. So another important API is the TFM health access to regions. It will use to check the input parameters for the client and service API. Yeah, and yes, I think it's all for these APIs.
Sorry, are you talking, which isolation level are you talking about here? So just all the 3 levels all following this sequence or the interface here?
So actually, the crate and the switch is for the isolation 2 and 3. The access region is for all the isolation levels. So because there has isolation initials in the platform init APIs, it will be used in the isolation 1 to isolation the skill and the non-skill part. So this API is just for the skill partition isolation.
I think this is for their it's a unified isolation interface for all the isolation levels. Just the implementation define the different actions during the interface implementation. For example, if we are calling the switch function in the isolation level 2, we may just not switch the detail boundary, but just change the privilege setting for the whole LUT and PLUT.
Yeah.
Yeah, for the isolation level 3, we may switch during their partition switching. We may change all the necessary update on the MPU or their MPC things, something like that. That's for example. And for the isolation level 1, maybe we don't need to call that. Even we to make the code looks unified, we may call it, but the implementation may be empty or just be optimized as empty, something like that. So it's a unified interface, not specific for the level 2 or level 3.
Okay, another question, please. So, can we assume that all this secure partition will run in a non-privileged state?
Yeah.
Okay.
Yeah, it should be works for the application root.
Yeah. Okay. So, and in case we want to share memory between two secure partition managers, between two secure partitions, is it something possible to share memory?
Share memory. Yeah, I don't think so, because in if we want to follow the PSFF, because all the data should be accessed through the PSC read and PSC write, and the SPM will help to transfer this data. And then we should not use the shared memory.
Okay, that's well, for me. That will be at a certain time. We would need probably to share some buffer or some data buffer between two secure partitions, because they can both communicate some data. Well, I'm just wondering.
For solution level 1 and level 2, and if these two partitions are unprivileged, or the application is root, So I think it's okay you share memory. So because they are in the solution regions, but for the solution level 3, I don't think so. You can do that.
One thing to amend is that there's a solution to give the possibility to share memory, but we need to get confirmed from the ATG guys, from the PSAFF. So that is the peripheral region. So each partition can get a mapped peripheral region for direct accessing some needed resources. So we can use that part if you are allocate a shared memory for 2 partitions. Both these partitions can assign this region in their manifest, and then the SPM will map that to the partition while it is running as a peripheral space.
Clear.
Yes, but we need to get confirmed from the PSU. Yeah.
Okay.
So if it is a load or something, yeah.
Thank you.
Okay. So next one is the log interface. So it is the simple, so just 2 functions here. The one is for the call log and the one is for the service log. And for the call log, it is for the flexible login device. For example, we can use memories, we can use serial ports, or maybe other devices, the USB, or maybe other device. So the last one is the interface, interrupt interface. So I just mentioned the config IRQ here. So this API is used to configure the parameter skill state, the probabilities of the IRQs. And here is some example of the structures. And it will include all the interrupts related to one SQL partition. Yeah. So for other 3 APIs, it is not. It should be similar as with the NVIC APIs. So, okay, so this is the patch link. So we have published the designs to the transformed ORGs and 2 weeks ago. And 6 it's still in discussion and in reviewing. So if you have any suggestions and comments, and welcome to give comments here, or mail list is also be okay. So it's all for the TF health, mainly focused on the TF core part. And if do you have any more questions about this?
Are there any questions to Edison about the new proposed hub? Looks like everything is clear and everybody like it.
Okay. Yeah, so if you have any comments, please give in the patch link. Okay, so I will stop sharing.
Sorry, Eric speaking. One question. In fact, previously Michel had a mic problem, so I will try to raise the question he was trying to ask. Somehow related to the measurement API that you introduced before, do you think that it could make sense to define or specify a minimum number of MPU descriptors, so defining a minimum number of regions that has to be supported?
So I think it should be okay because you know all these API, all these HEL APIs is just weak functions, and we will give some examples in this in the implement of these APIs. If you want to change the scope, change the implement, and if you want to add some more features, for example, the MPUs, I think they should be relating to.
Even in the let's say standard feature of TFM, for instance, when we'll move to or introduce isolation level 3, we believe that the number of MPU region to support will increase compared to level 2. And this may require different capabilities of the chip to define a certain number of regions, and maybe good to define or specify this minimum number of regions.
Yes, I agree. I agree. I think what we need is the minimum the recommendation for the minimum set of MPU region to support the task, I would say the secure partition, isolation, and switching task.
So which means sounds like you want more information to be given in the measurements, not only just the features, right, or the components to be initialized. So for isolation level 3, it's a special case because they are minimum. Okay, for minimal, if it's okay, we can define a minimal requirement for the regions or the hardware, something. Yeah.
Yes.
Yeah, but you know it is. Yeah. But you know, some other things are flexible and could affect that. For example, the peripheral regions used in a partition. If a partition uses more than 1 or 2, which means that the partition can have multiple peripheral regions. So which means that it will need more MPU regions for that. So in that case, that is flexible. So for a minimal set, then we can define a minimal set. And I think that can be covered in the isolation level 3 design document, I think.
Yes, I think this is just to make sure that people implementing the global solution at SOC level, they don't miss this parameter, which is important. If, for example, the minimum recommendation is 8 region, and the people choose a configuration of the CPU with a 4 region, it might be a problem. So I think you should have a kind of guidelines and recommendation for the minimum configuration of the CPU that will be comfortable with handling this secure partition manager and this isolation level 3. That's I think that's something that
that's a good feedback. That's a good feedback. I can say in the isolation design spec, we would say that we would mention that. Yeah.
Okay, thank you very much.
Any other questions? If there is no other questions, I think we can. By the way, any questions not related to the HAL presented today or any other topic that was discussed on the mailing list or any other concerns? So this is our best opportunity to discuss it quickly and the proper people. I would remind that there is a patch committed by Min Yang as a follow-up of the previous discussion of introduction of alternative way for linear handling. Also, please advise you take a look and give your feedback. There are already many feedbacks, but I think it's quite interesting and important topic.
Yes. Let's experimental patch to collect the feedbacks for the for the veneers, because in the existing library model, we got many veneers. So now we are converted it into with only one veneer with different dispatch code, something like that. So that is for collecting their recommended collecting the feedbacks, because we assume that there are many people are using the library model. So please do feedback.
Yeah, right. Thank you, Ken. Okay, if there are no more questions, I think we can close it today ahead of the time. And thank you, Edison. Thank you very much for the good presentation. Thanks everyone who joined us today. Have a good day. Bye.
Okay.
Thank you. Nice
Okay.
Thank you.
presentation. Thank you.
Bye.